In this video, we're going to talk about a conic section, and there's three main kinds, or technically four kinds of conical sections, and that includes the parabola, an ellipse, and a hyperbola. A conic section is when I take a plane, and look here in yellow, and I have three cases. So basically, you have a three-dimensional cone. Kind of looks like an hourglass, where, well, maybe look here on the far right. So I have a three-dimensional cone on the top, and a three-dimensional cone here on the bottom. And if I have an intersection between that cone and a plane, I can form three different kinds of conic sections, where the conic section's the intersection between the plane and the cone itself. And one way for it would be the intersection of the plane and the cone would be to form a parabola. A second way would be an ellipse, which I am going to kind of group together the ellipse and the circle. And then a third one would be a hyperbola. And in this video, we're going to focus on the conic section of the parabola here, which the intersection between the plane and the cone forms a parabola. And a good example of a three-dimensional parabola is a flashlight and or a satellite dish, because a lot of those are three-dimensional paraboloids where I have my parabola, and if I spin it and form a three-dimensional section, the cool thing that happens with parabolas is you have a reflective property, where if something comes in, let's say like a transmission, or actually let's do a flashlight. Let's say I have my bulb, my flashlight right here, where the light bulb itself emits rays of light in all directions. Now, what happens is the light will hit the parabola, the edge of the parabola, and will come out, and all of these rays here will wind up forming and being parallel to one another once they reflect off the edge of the parabola. Likewise, if they were going the other way, let's say I had a satellite dish, and this was my satellite dish here. The transmission from the satellite would come in, it would hit the edge of the parabola, or the dish itself, and the transmission would reflect itself back through this point. Well, this point where everything reflects through is called the focus. So let's look at the conic section of the parabola. And we're going to define a parabola as a set of all points in a plane equidistant from a particular line called the directrix line, and a point called the focus. And if I generate a general equation for a parabola written in transformational form, we get these two general forms here, where I have x minus h squared is equal to 4p times y minus k, or y minus k squared is equal to 4p times x minus h. Now, if x is being squared for a parabola, it's going to open up or down. If y is squared, it's going to open sideways. It's going to either open right or left. Now, a vertex is going to be h comma k in both instances. So that's how I would find my vertex if it's written in this form. Now, to determine if the parabola opens up or down or right or left, we look at the sign of this 4p here. If written in this form, if 4p is positive, the parabola is going to open up, or it's going to open right. If 4p is negative, it's going to open in the negative direction, which would be down or left. Which brings us to the question of what in the world is p? P represents the distance from the vertex to the focus, or the distance from the vertex to a point called the focus. So the distance from the vertex to the directrix, or the distance from the vertex to a focus, is p. Now, from that, we can determine 2 points that lie on the edge of a focal chord. The endpoints of a focal chord from the focus, it's parallel to the directrix line in either case, either vertical directrix or horizontal directrix. The distance from that focus to a point that lies on the parabola is 2 times p in either direction. 4 times p is the focal width, so it's the width of that chord from endpoint to endpoint. All right, so we're going to do a couple of examples here where we're given the equation of a parabola in this transformational form. We want to analyze it in terms of what it would look like geometrically, and then we want to graph it. So here I'm given the equation 1/2 times y plus 4 is equal to x plus 2 squared. And I'm looking at this in the general form. I have x being squared, and the number in front of the non-squared factor is positive. This parabola is going to open up. The vertex here, h comma k, is going to be it should be x minus a number, comma, y minus that number. Well, it's going to be my vertex to be -2, comma, -4. The focal width, which is equal to 4 times p, is going to equal 1/2. So my focal width is 1/2. Now, to help us find where the focus and the directrix are, we need to solve for p. So I would divide by 4. P is equal to 1/8. P represents the distance from the vertex to the focus or the directrix line. So if we open upward, so if I just make a rough sketch, I open upward. All right, my focus will, so there's my vertex. My focus will lie above the vertex. So I would write the coordinate of my focus, would have an x value of -2. The y value would be -4 plus 1/8 would be -31/8. The directrix line would lie beneath the vertex and would be a horizontal line. So it would be, the directrix line would be at y equals -33/8. And so now we want to put all this information on the graph. And so I'm just going to make a scale with just the important information. So here at the very middle, I'd have my middle x value -2, and vertically I'd have my middle y value of -4. That's where my vertex is going to lie. We open upward, so my focus would be above this. All right, and the y value of the focus is -31/8. And so we have that there, and our directrix line would be -33/8. And it's going to be horizontal, so we'll make a dashed line here for my directrix, and I'll just label it. Now we want to get two other coordinates that lie on the parabola, so that way we could increase our accuracy. Now we're going to have the endpoints of the focal chord. Now the distance from the focus to either of these endpoints is going to be 2 times p in either direction. So I could get the x values of those 2 points by taking the x value of my focus, which is -2, and adding or subtracting 2p from it to get to the x value on the right and the x value on the left. We add that 2p and we get a right value of -1.75 and a left value of -2.25. And so now we can sketch our graph to go through those points. And I know it's not drawn to scale, but we have the appropriate values. Okay, let's look at this next one. We have the value -4, the parabola equation, -4 times y plus 2 is equal to x minus 6 squared. Now, how do I know it's a parabola? Just by looking at the equation. A parabola will only have one squared variable. So either x or y will be squared, but not both. And x is being squared, so it has to open vertical because I have a negative coefficient over here, and that means it's going to open downward. So we can go ahead and write it opens down. And now we want to identify our vertex, where that's going to be. Our vertex, we should have x minus h. Well, h is the x value, so h is 6 here. And y minus k, well, this means k is going to be -2. So I have the location of my vertex. Now the focal width is the 4 times p number. Well, our focal width is going to be positive, so 4p is equal to 4. So that's the overall width of the focal chord. Now to help us find the focus, we need to solve for p. So I divide by 4, p is equal to 1. Now, since we open downward, the focus is going to lie beneath the vertex. And so I would take my coordinate of my vertex, keep the x value the same, subtract p from the y value, so the y value would be at -3. The directrix line will lie above the vertex, so I would take my y value, it's going to have a horizontal directrix, and we're going to add 1 unit to the y value of the vertex, so I get y is equal to -1. Now we want to put all this information on a sketch. Well, I would just put my x value for my vertex here in the middle if I'm just going to make a scale. Now this is a rough sketch, not drawn to scale. And we know our directrix here has a y value of -1. And so that's my directrix. We have our focus that lies beneath the vertex, has a y value of -3. We'll label that with the F here. And so we have that information. We want to get the endpoints of the focal chord, so that way we have 3 points that lie on the parabola to help us sketch with. Well, we get the other 2 points that are going to be the endpoints of the focal chord to the left and the right, because the distance between the focus and either of those points is 2p, which is the same thing as half of the focal width. Our focal width was 4, so if I add 2p or subtract 2p, I'm going to get x values here of 4 and 8, where I have the endpoints of that chord, and now I can sketch my parabola that goes through there. All right, so here in this problem, well, look, we have negative 3 times x minus 2 is equal to y minus 6 squared. This time we have a variable y being squared, so it has to open left or right. And to figure out which way it goes, we look at this coefficient. This coefficient is negative, so it has to open in the negative direction, which the negative direction along the horizontal will be opening towards the left. And so this is our orientation, so we open to the left. Our vertex should be x minus h, y minus k, so we identify our variables there, or our constants, so it should be at 2, 6. The focal width is 4 times p, which I'm ignoring the negative sign here because this is a length, and so we get focal width of 3 units, which means that p is equal to 0.75. Now our focus, if we open to the left, has to be inside of the opening, which for this parabola means it would have to be on the left side of the vertex. So I would keep the y value of my vertex the same, and I would subtract p from the x value of my vertex to get the x value of my focus. And the x value of my focus here is going to be 5/4. Now my directrix line, this case, would be located to the right of my vertex, and the distance it is from the vertex is also p units. It's a vertical line, so we're going to write it in terms of its x value. So I'd add p to the x value of my vertex, would be 2.75, which I could write as a fraction as 11/4. Now we'll put all this information on our sketch here, and so we'll get my x values. I have an x value of 2, we got an x value of 11/4, and we have an x value of 5/4. The one y value we have is the y value of our vertex, so I'll put a dot there, I'll label it V. We have the directrix line, which is located here to the right at 11/4, so that's my directrix, and the focus is located to the left of that vertex, and so this is what we have. To graph this, we want to get the endpoints of the focal chord, so I need to get the point that lies above and below. And so to do that, we're going to add 2p to the y value of the focus. I'm going to add and subtract 2p, and that's going to give me my 2 endpoints. Well, if I add and subtract 2p, I can get a y value of 7.5 for the top endpoint of the focal chord, and I get one of 4.5 for the lower endpoint of that focal chord, and then I connect those dots here and have my sketch. All right, next one, we have x minus 2 is equal to y plus 2 being squared. So here in this case, we have another parabola where y is being squared, and which means it has to open along the horizontal, so it's either going to open to the right or the left. Since the coefficient of the non-squared term is positive, the parabola is going to open in the positive direction along the horizontal, which means it's going to open to the right. So this is going to be my orientation. Now from here, we will identify our vertex. Our vertex, when it's written in this form, would be, we'd have an x value of 2 and a y value of negative 2. The focal width would be 4p. Now it's not technically written as factored, but really there's a 1 right there, which means that 4 times p is equal to 1. My focal width is 1 unit. Now we can solve for p to help us find our focus and our directrix. P is going to be equal to 1/4. And so we can identify our focus. Well, if we open to the right, the focus has to be inside of the opening, which means it'll be to the right of my vertex. So I take my vertex and I would add p to the x value here, and so my focus would have an x value of 2.25, and it'd have a y value of negative 2. My directrix line would have to be to the left of the vertex, and it's a horizontal line, so it'd be x is equal to, and I take 1/4 away from the x value, so it'd be 1.75. Now we'll put all this information on our graph. So we'll get our vertex information. We have 2, y value of negative 2, so there's our vertex. Now we're going to open to the right, so our focus would be to the right side of this. We got the x value of the focus of 2.25, y value is still at negative 2, and the directrix line's at 1.75. And so I have this vertical line here. I'm going to identify it and label it directrix. Now we want to get the endpoints of the focal chord, so we get 3 points that lie on the edge of the parabola. The endpoints of the focal chord are 2p away from the focus in either direction. So we're going to add and subtract 2p to that y value of negative 2 to get those y values. So we have one y value of negative 1.5, one y value of negative 2.5, and then we can connect and make our sketch through those points there.